From all of our stations, Station 5 is the most difficult and yet most important concept of comparing and ordering. Because to be able to order something from smallest to greatest, you have to compare the number beside it. So either way, whether you're ordering, you need to know what to do when comparing. So in your notes, I believe you had 3/5 and 2/5. Which one is bigger? And this one is easy to see that, well, 3 is greater than 2, therefore 3/5 must be greater than 2/5. And the primary reason for being able to do this is that our denominators are the same. And what that means beyond we just have to get same denominators is they're cut into equal pieces. So if we were to sketch it, and remembering sketches aren't perfectly accurate, 3, 4, 5, we can't just go on a sketch. Because if we had 21sts and 23rds as our denominator, it's going to be a lot harder to try and accurately show that this 3 more pieces is larger. But now what happens when you have, what happens when you have unlike denominators to start with? So if we had 2/5 comparing that to 1/3, well, I need to be able to cut these into equal pieces. So if I have, let's see if I can do this. If I have fifths, 1, 2, 3, 4, 5, assuming those were all nice and equal, we have 2 colored in, 2 out of 5 colored in, and then I have thirds. If you overlap, and one of these, if you overlap the blue writing or the blue sections of these two, how many pieces are you going to have? Well, you have your thirds and you have your fifths. 2, 3, 4, 5. How many pieces do I have in total? Well, I have 15. That's my new denominator. So if I was to add that, let's see what we got here, to here, 1, not a good color, 1, 2, 3, 4, 5, how many pieces, which was once a third, how many little pieces are there now? Well, there's 5 of them. If I did the same thing up here with the original fifths, but then thirds, I have 15 pieces now. The original 2/5, now if we compare them as 15s, have 6. So how do we do this without drawing? Because even drawing 15s is tedious. So we need to look for common multiples. So 5, 10, 15, 20, 25, and so on. And 3, 6, 9, 12, 15. So I don't have to go any further because I notice they have something in common. So I'm looking for my common multiples, and that creates my common denominator. And using multiplication, how does a 3 become a 15? Where I'm going to multiply by 5, and 5 becomes 15 because I multiplied by 3. My rule is what I do with the denominator, I do with the numerator. So what I do at the bottom here, 3 times 5, I also have to do to the top. So 1 times 5 is 5. What I do at the bottom here, I also have to do to the top. Times 3 is 2 times 3 is 6. So I've created equivalent fractions from the 2/5 to the 3/15, or from the 6/15, from the 1/3 to the 5/15. Created 2 sets of equivalent fractions, but now because they're broken into equal pieces, I can just compare that 6 is bigger than 5, so 6/15 is bigger than 5, therefore 2/5 is greater than 1/3.